And it's allowing researchers all over the world to collaborate and build on top of each other's work. So how do we bring the power of LabVIEW and ROS together? Well, to do that, we turn to another partner, Tufts University in Boston, Massachusetts. Now, I first visited Tufts almost 18 years ago to support a professor who was doing research on how to use LabVIEW to program the early LEGO Mindstorms platform. And that research sparked a relationship between NI, Tufts, and LEGO that essentially revolutionized educational robotics by empowering millions of children around the world to build LEGO robots and program them graphically with a customized version of LabVIEW. And here today to tell us more about what he and his team have been working on with LabVIEW and ROS, please welcome Chris Rogers.
So about 5-6 years ago, one of my master's students graduated and got a job, always a good thing, at Rethink Robotics, which was a new startup that had just happened in Boston. And so of course we needed to get one of these for the lab, since you always have to support what your students do. The problem is it runs on ROS, and there was no LabVIEW ROS version. So we started to develop one. So ROS has a number of big advantages if you can get it all to work. First is it's open source. It's a standardized format for communication between computer and robot. So if you get it working on one robot, it works on other robots. And it's peer-to-peer, so that is that every control that you do from the computer to the robot has its own separate server. And so what we did is we developed a LabVIEW interface that tried to make all this work. And so what LabVIEW does is it will talk to Baxter, ask the master for control over some part of the Baxter, it could be the head or the arms, and sets up a separate server that runs continuously just talking to, say, the arm. And then your code actually talks directly to that server. So let me show you how that can work. So if you are doing it the old-fashioned way, you would write text. Say you want to know where the joints were, you'd write text and it would send you back text. If you wanted an image, you would ask for an image and it would send you back an image. But in LabVIEW, we replace the text by pictures, right? So you have a VI that will grab the joint position for you and send it back to the cluster, or another VI that will send you back an image that the camera sees. So it makes it a little bit easier to debug and a little bit quicker to program. And so, for example, we brought in a bunch of Girl Scouts and they programmed Baxter to actually serve Girl Scout cookies. Something you always need, a $25,000 Girl Scout cookie server. Plus, because it's in LabVIEW, you're able to use all the different modules that LabVIEW has to offer. And so you can couple it with the true power of LabVIEW. So let me show you how that all looks. Let's actually do a demo. So to do a demo, we wanted to come up with something that was fairly straightforward for you guys to see. And what we thought we would do is just control this arm with this joystick. So we can connect up the joystick, and you have the standard LabVIEW joystick control commands. And we do some math to convert the joystick to a reading, and then we want to send that out to our Baxter's arm. So we can connect that up and hit run. And what will happen now is it sets up the servers, and as we move the joystick around, you can move the arm around. Pretty cool, eh? All right, but that's not cool enough. We might want to do a little bit more. So if we go ahead and stop that from running, and we want to actually see underneath the arm is a camera, we want to see what the camera is seeing, we can say let's drop a new topic or a new server for the camera, and then we can say we need to convert from data to a graph, to a plot, a picture. So we can do that. And now we've got our little picture display, which we can make a whole lot bigger, and hit run. And now you can actually see what the camera underneath his arm is seeing. So you can actually see the Girl Scout cookie that you need to pick up. So the idea is it's fairly straightforward to program at the Baxter, but wouldn't it be cool if you could actually then control the Now robot with that as well? Since there is a ROS driver for the Now robot, you can now use the same VIs, the same program, and make the Now robot walk. Or you can start to use the robo-Rio that Ray was talking about. So we can actually embed a master on here. We can connect up the joystick in the same way. And then we can start a little LabVIEW server running a ROS master and a ROS client on the robo-Rio. And suddenly we can now move our robot around as well and maybe grasp things, maybe drive forward or backwards. Oh, come on, that's pretty cool. Try it out again to make it look a little better.
That's great, Chris. So using LabVIEW and ROS, you can easily move around all of these different robots. On the robo-Rio, could you tell us a little bit more about your experience with robo-Rio?
So the robo-Rio is nice in that it already has all the connectors for the servo motors and so on, so it made it pretty easy for the students to use. This robot actually was built by 2 undergraduates from Barcelona who were visiting the lab for the month of July. They had never really done ROS or Rios or LabVIEW before, so we gave them the whole thing and they designed and built this and got it to run, as you can see.
That's great. So could you tell the audience how they can help and how you can get the LabVIEW ROS toolkit?
So this is all very much still in beta. What you didn't see is last night us trying to make sure everything would work. So we would really appreciate help on this. It's all open source. You can, if you go to the LabVIEW Tools Network, you can get the VIs. Please download them, try them out, tell us where you have bugs, and then start contributing towards it and make it so that we can drive more robots easily. So that someday anybody can just, if they get a Now or they get a Baxter, be working in the lab within 15 minutes and have it already doing what they want.
That's great, Chris. Thank you very much.
Thanks.